Welcome to Archicraft, a bit of architect, your go-to podcast for modern software and solution architecture, enterprise strategies, and AI-powered engineering. Each episode is AI narrated, based on the original blog content by Dima Golodiuk at demongo.com.
You're listening to the 13th episode of the podcast. This episode is titled AI-Driven Forecasting Architecture in Enterprise. In this episode, we explore an integrated architecture for advanced enterprise analytics. This blueprint integrates predictive, prescriptive, and cognitive analytics to enhance decision-making. Let's get started.
Welcome to the Deep Dive. Today, we're cutting through the noise to get you informed fast. Look, the business world today, it's just incredibly complex, isn't it? Dynamic, doesn't even begin to cover it. Markets shift constantly. Customer behaviors seem to change overnight, and we're all swimming in this ocean of data.
Absolutely drowning in it sometimes.
Exactly. And in this kind of environment, just relying on traditional business intelligence, that old rearview mirror approach, looking at what already happened, well, it just doesn't cut it anymore. Would you agree?
Oh, absolutely. The era of simply reacting, of looking backwards, it's decisively over. I mean, if you're an organization that really wants to lead, not just follow, the strategic imperative is crystal clear. You have to shift. You've got to move from being reactive to being proactive, driven by real foresight.
Okay, foresight.
And that's what we're diving into today. Think of this as a shortcut, really, to understanding a pretty definitive blueprint for making that shift happen.
And our guide for this is a really insightful post from Dmytro Golodiuk-Dime, we'll call him. It's titled AI-Driven Forecasting Architecture in Enterprise. Now, this isn't just, high-level theory.
Not at all.
Dima actually lays out an end-to-end architecture, one that properly integrates predictive, prescriptive, and even cognitive analytics. It feels like a real game changer for how businesses operate and make decisions.
It really is. And our mission today, essentially, is to unpack that blueprint. Whether you're a senior leader trying to set strategy, maybe a business owner looking for that competitive edge, or perhaps an enterprise architect designing the systems of the future, we want to focus on the strategic side.
Right, the how-to.
Exactly. How do you actually realize this? How do you implement an AI-driven forecasting architecture? Not just for the cool tech, but for what it actually does. Genuinely enhance decision-making and give you a real, lasting competitive advantage.
So to really get our heads around this blueprint, I think we first need to understand the journey of analytics itself. How we got from just looking backwards to actually trying to steer towards the future.
Precisely. And Dima's article lays this out very nicely, starting with what people often call the analytics maturity model. It's basically a progression, stages an organization goes through. So stage one, the most basic, is descriptive analytics.
Okay.
This is your what happened stage. Simple as that. It's about summarizing historical data. Think quarterly sales reports, website traffic dashboards, standard BI stuff. It gives you that crucial snapshot of the past.
Got it. Step one, know what happened.
Then building on that, you get to diagnostic analytics. Now you're asking, okay, why did it happen? You're digging a bit deeper, looking for root causes, maybe analyzing why a specific sales campaign didn't perform as expected, or figuring out the exact reason a piece of machinery failed on the factory floor. Still focus on the past, but with more depth, more understanding.
That makes sense. Knowing what and why is essential groundwork. But like you said, it still feels like we're looking backwards, reacting. Where does the real leap towards foresight happen?
That's where predictive analytics comes onto the stage. Now we're asking, what will happen? This is where you start using historical data, yes, but also statistical models, machine learning, all aimed at forecasting future outcomes.
Okay, now we're talking future.
Yeah, things like sales forecasting, demand forecasting, predicting which customers might leave churn prediction, or even spotting potential cyber threats before they hit. But it's not magic. It's a multi-step journey. You need careful data collection, preparation, cleaning, and then something called feature engineering.
Feature engineering. Sounds technical.
It is a bit, but think of it like this. It's the art and science of taking your raw data and transforming it into the signals that are most useful for the AI model. Like a detective sifting through clues to find the ones that actually matter for solving the case. You're helping the AI focus on what's truly predictive.
Okay, so we've cleaned the data, engineered the features, and now we can predict what's likely to happen next. That's definitely powerful. But just predicting, well, it isn't enough for business, is it? We need to know what to do about it. How does the architecture help us move from prediction to action?
And that's the crucial next step, prescriptive analytics. This takes prediction and elevates it to direct action. It answers the really critical question, okay, so what should we do now?
Right, the recommendation engine.
Exactly. It combines things like optimization algorithms with the AI models to actually recommend the best course of action. So imagine a system that doesn't just predict future demand, but actively suggests the precise inventory levels you should hold. Or maybe it dynamically adjusts pricing in real time based on predicted demand and competitor actions.
Okay, I see.
Or for a logistics company, it might mean automatically rerouting trucks based on live traffic data and weather forecasts it's predicting. See, this isn't just about generating insights anymore. It's the catalyst for automated intelligence strategies. It starts doing things for you.
So we've gone from understanding the past, predicting the future, to being told what to do about it, what's left. Is there a higher level on this maturity model?
There is. The pinnacle, as Dima describes it, is cognitive analytics. This stage asks, how do we think and reason? The goal here is to mimic human cognitive functions, things like learning, reasoning, complex problem solving. And crucially, it can handle both structured data, like numbers in a database, and unstructured data, like text or images.
Wow. Okay. Like what?
Think about chatbots that don't just follow scripts, but actually understand the context and nuance of your questions. Or risk management systems that can analyze market sentiment from news articles and social media, not just stock prices. In healthcare, maybe systems recommending personalized treatment plans after analyzing millions of research papers, something no single doctor could ever do. It's truly about augmenting human intelligence at scale.
That sounds incredibly powerful, but are these like separate silos? You do descriptive, then diagnostic, then predictive, or is the real magic in mixing them?
That's the key point Dima makes. The real transformative power comes when you integrate these stages. It's not a series of isolated steps. He calls it a tightly connected continuum.
Okay.
Think about that logistics company again. You connect the predictive traffic forecasts directly with the prescriptive routing actions. So you're not just saying there might be a traffic jam. The system automatically reroutes the truck around it, minimizing delays, saving fuel, cutting costs. That integration is where you unlock really significant efficiencies and strategic advantage.
So this whole journey, this continuum from hindsight to foresight, it sounds great conceptually, but for, say, a busy CEO or a business owner, what's the bottom line? What does this actually change inside the company day to day?
Well, fundamentally, it's a paradigm shift in how decisions get made. You're moving away from decisions that are purely human-centric, maybe data-informed if you're lucky, towards decisions that are genuinely AI-augmented. But the core insight here for leaders, I think, isn't just better decisions. It's about completely rethinking your talent strategy. Imagine freeing up your smartest, most expensive strategic thinkers from doing repetitive, low-value data crunching or report generation. Imagine them actually having the time and the AI-powered tools to truly innovate because the AI is handling the grunt work. Think about finance professionals moving beyond basic data entry or reconciliation to focus on complex strategic risk monitoring or optimizing capital allocation. That fundamentally changes an organization's ability to compete.
Right, freeing up human potential. Okay, with that foundation set, let's get into the nuts and bolts. Let's unpack the architectural blueprint itself. How do we actually build this AI-driven forecasting capability? Dima's article gives us these distinct interconnected layers.
Indeed, and it absolutely has to start with the data and infrastructure layer. This is non-negotiable. It's the foundation. Without solid ground, nothing else stands up.
Makes sense.
It begins with data ingestion and storage. You need the capability to pull in and handle massive amounts of data and diverse types, to structured stuff from your CRM or ERP systems, unstructured data like social media feeds, maybe sensor data from IoT devices, and it needs to handle both real-time streams and big batches of historical data.
And the standard for that now is?
The modern standard, as Dima points out, is really the data lakehouse architecture. It's kind of the best of both worlds. Imagine having the structure and governance of a traditional data warehouse combined with the flexibility and scale of a data lake. All unified. It lets you handle all sorts of data for all sorts of analytics tasks.
Okay, lakehouse. Got it. Then what?
Then comes processing and transformation. Raw data is almost always messy, so you need processes to clean it, enrich it, maybe combine it with other data sources, and transform it into a usable format. This includes that crucial feature engineering step we talked about earlier. For doing this at scale, tools like Apache Spark are pretty much essential. Trying to process huge data sets with older tools is like, well, trying to move a mountain with a teaspoon. Spark provides the heavy machinery.
So data foundation sorted. We have clean processed data ready to go. How do we then actually put the AI models to work reliably in the real world? What's the engine room?
That engine room is the MLOps and orchestration layer. MLOps, machine learning operations. This is absolutely critical. It bridges that often tricky gap between data science experiments or models built in a lab and actually deploying them into production where they deliver real business value. It's about managing the entire machine learning lifecycle rigorously, focusing on continuous improvement.
Okay, MLOps, what does that involve?
A core part is the end-to-end pipeline. This automates the whole workflow. Getting the data, pre-processing it, training the model, validating it, deploying it, and then monitoring it. Key components here are things like data orchestration tools, experiment tracking. Dima mentions MLflow, which acts like a detailed lab notebook for every AI experiment you run, and a model registry to keep track of different versions of your models.
So it's about making AI reliable and repeatable, not just a one-off experiment.
Exactly. For a business owner, this means your AI isn't just a clever project. It's becoming a dependable, constantly improving operational asset. This layer enables continuous improvement using CI/CD principles, continuous integration and continuous deployment, but applied to machine learning. Think of your AI models constantly learning from new data, getting retrained and redeployed automatically, ensuring they don't degrade over time. Tools like Docker and Kubernetes help package and deploy these models consistently, while monitoring tools like Prometheus and Grafana act like a dashboard, keeping an eye on performance and accuracy.
Okay, so the engine is running smoothly, the models are being updated, but how do we get those valuable insights, those predictions and recommendations, out to the people and systems across the business that actually need them?
That's the job of the application and delivery layer. Its whole purpose is to expose that intelligence securely and usefully. A key part of this is API-driven delivery.
APIs, application programming interfaces.
Right. Insights, forecasts, prescriptive actions, they get delivered through well-defined APIs and often microservices.
Yeah.
This allows them to be seamlessly integrated into the business applications people already use, your CRM, your supply chain software, maybe a custom dashboard. It's about embedding the intelligence where the decisions are made.
Makes sense. Not just a separate report people have to go find.
Precisely. And the other aspect is interface and accessibility. You need user-friendly ways for people to interact with this intelligence. Things like self-service BI dashboards, visualization tools. The goal is to democratize access, so it's not just data scientists who benefit, but business analysts, managers, leadership, a wide range of users can get the insights they need.
And sitting right at the heart of all these layers, the actual brain of the operation is the intelligence itself.
Correct. That's the AI model layer. This is where the algorithms live, the models that actually generate the forecasts, the predictions, the recommendations. A good architecture needs to support model selection, meaning it can handle various types of models.
Right.
Well, you might need traditional machine learning models like linear regression or random forest for analyzing structured data, but you'll likely also need deep learning models for dealing with unstructured data like text or images, and maybe even reinforcement learning for optimizing really complex dynamic systems like inventory control or pricing strategies.
So flexibility is key.
Absolutely. And to manage all this effectively, especially at scale, automated model development becomes really important. Dima highlights AutoML platforms. These tools can automate some of the really time-consuming parts of building models, like selecting the best algorithm type or tuning all its internal settings. That's hyperparameter tuning. AutoML helps speed up the process of getting effective models into production much faster.
It certainly sounds like a well-thought-out, layered system, but Dima really emphasizes that having this unified architecture isn't just a nice-to-have. It's basically essential, isn't it?
Exactly. He makes it clear it's a foundational prerequisite. Why? Because data silos are the enemy here. If you have critical information locked away in separate, disconnected systems, your CRM over here, ERP over there, marketing platforms somewhere else, your AI simply cannot get a complete enterprise-wide view.
Right. It's working with incomplete information.
Precisely. You end up with fragmented insights, maybe conflicting forecasts, instead of a single reliable source of truth for foresight. It fundamentally undermines the whole point of the exercise. You need that unified view.
Okay, so we understand the blueprint. But building this isn't just a tech project, is it? Dima stresses it's a strategic business transformation. So thinking about actually integrating this and implementing it, what's the role of the enterprise architect in all this?
The enterprise architect becomes absolutely pivotal. Their role really evolves here. Traditionally, EA might have been seen as a bit static, mapping out systems periodically. But with AI, we're moving towards what you might call dynamic EA, continuous monitoring, continuous adaptation. The architect acts as the crucial bridge between the high-level business strategy and the nuts and bolts technical implementation.
So they connect the vision to the reality.
Yes. They assess the current systems landscape, identify capability gaps, make sure the AI initiatives align directly with strategic business goals like reducing costs or improving customer experience. They model how changes will impact the enterprise, pinpoint data gaps, and crucially, they help standardize data governance. They lay that robust data foundation we talked about earlier.
So practically speaking then, for a business owner, a CIO, maybe a CTO listening, how do you actually start this journey? It sounds potentially massive, even overwhelming.
And that's why a phased approach is so critical. You don't try to boil the ocean. It's about mitigating risk and, importantly, showing value early on. Step 1 is foundational readiness.
Okay, what does that mean?
It means doing a really honest self-assessment. What are your current forecasting methods? Are spreadsheets still the primary tool? What's the real state of your data infrastructure? Do you have the right skills in your teams? And critically, Dima stresses, establish a clear governance charter right from the beginning. Don't treat governance as an afterthought.
All right, assess readiness, set up governance.
Step 2, develop and validate a pilot. Start small. Pick a single well-defined business problem, something with clear objectives where you have a good chance of success. Focus on achieving quick, measurable wins. Maybe it's reducing shopping cart abandonment on your website or cutting down on unsold inventory in one product line. The goal here is measurable ROI to get that crucial executive sponsorship and build momentum internally. Show it works.
That makes sense. Build confidence, get buy-in with a tangible success story. What comes after a successful pilot?
Then you move to step 3. Build a production-ready pipeline. This is the big leap, taking what you learned from the pilot and engineering a truly scalable enterprise-grade system. This means building out that formal MLOps pipeline we discussed, automating the whole workflow from data prep to model deployment and monitoring, and importantly, building it with continuous improvement baked in from the start.
So pilot, then build the robust engine, and finally...
Step 4, scale and integrate. Now you expand the framework. Apply it to more complex, higher-impact business problems across the enterprise. This involves integrating the AI capabilities into core business processes via APIs, standardizing your data models for consistency, and often redesigning how humans and AI work together on teams. The ultimate goal is to break down those departmental silos and move towards a unified, enterprise-wide solution where AI forecasting is just part of how you operate.
It's easy to get carried away with the technology here, but you mentioned it earlier, and Dima's article really hammers this home. The human element is absolutely crucial. We've all heard stories of AI projects that failed, not because the tech wasn't good, but because the people aspect wasn't handled well. How do you ensure that part is successful?
You're spot on. It's often the make or break factor. Firstly, strong, visible executive sponsorship is non-negotiable, and you need clear business goals tied directly to the AI use cases. Everyone needs to understand why you're doing this. A major hurdle can be employee resistance, often stemming from fear of job losses.
Right, the AI is coming from my job fear.
Exactly. And the way to tackle that is by actively reframing AI. It's not primarily about replacing people. It's about augmenting human capabilities. It's about letting the AI handle the repetitive, mundane tasks so your talented employees can focus on higher value, more creative, more strategic work. But this requires investment in building a culture of collaboration between humans and AI, and investment in AI literacy across the workforce. Helping your teams understand what AI can and can't do is essential for making this transformation stick.
So much power, so much data. It definitely raises some serious questions.
That's precisely why Dima labels AI governance as a mission-critical enabler. It's not red tape. It's fundamental to building trust and ensuring responsible AI use. Think of it as the guardrails. It provides a structured framework for assessing your AI plans, implementing them safely, and making sure they align with your business objectives and your ethical standards.
So what are the core components of good AI governance?
It rests on several key pillars. First, data management, ensuring the data used to train your models is accurate, high quality, representative, and compliant with regulations. Rubbish in, rubbish out, basically. Second, transparency and explainability. You need mechanisms so your models can, at least to some degree, explain why they made a particular decision or prediction. This is vital for building trust, especially for users, and often required by regulators, particularly in fields like finance or healthcare.
That explainability piece feels huge for getting people to actually trust and use the AI's output, especially if it contradicts gut feeling.
Absolutely. Then there's accountability. You need clear roles and responsibilities defined across the entire AI lifecycle. Who owns the model? Who's responsible for monitoring it? Often this involves setting up some kind of AI governance board or council. Next, continuous monitoring and auditing is crucial. You need to track model performance, watch for bias, ensure ongoing compliance in real time, not just once a year. And finally, underpinning everything is data privacy and security. This means robust measures like data encryption, strict access controls, maybe techniques like anonymization or pseudonymization to protect sensitive information, especially with regulations like the EU AI Act setting a very high bar.
You mentioned bias there. That's a huge topic, and rightly so. There are so many concerns about AI inheriting or even amplifying societal biases. How does the blueprint help tackle that?
It's a paramount concern, and governance is key. AI models can absolutely perpetuate or even worsen biases present in their training data. If your historical data reflects past discrimination, the AI might learn and automate that discrimination. We need to understand the problem bias can come from skewed data, flawed assumptions during model building, or just reflecting existing societal inequities. Dima's article gives a subtle but powerful example of measurement bias.
Go on.
An algorithm was designed to predict healthcare needs, but was explicitly told not to use race. However, it used healthcare cost as a proxy for need. Historically, due to the systemic issues, less money was spent on Black patients' healthcare. So the algorithm, using cost, ended up flagging fewer Black patients as needing extra care, even though their health needs might have been greater. It shows how bias can creep in indirectly.
Wow, that's a really stark example of unintended consequences. So how do organizations actively try to prevent that?
It requires a really proactive, multi-pronged strategy. First, you need diverse and representative data sets for training. Second, rigorous testing and validation before deployment, specifically looking for biased outcomes across different groups. Third, using fairness-aware machine learning techniques designed to mitigate bias. Fourth, continuous auditing of models in production. And finally, Dima recommends a human-in-the-loop approach, keeping humans involved to oversee, validate, and potentially override AI decisions, especially in sensitive areas. It's about checks and balances.
Okay, so even if you build a perfect, unbiased model initially, the world changes, right? Does the model stay relevant?
That's the challenge of model drift and data integrity. You hit the nail on the head. Even the best model's performance can degrade over time if the real-world data it sees in production starts to differ significantly from the data it was trained on. It's like your map becoming outdated because new roads were built.
Model drift. Okay. Are there different kinds?
Yes, generally three main types. Concept drift is when the underlying relationship between the inputs and what you're trying to predict changes, maybe customer preferences shift seasonally. Sudden drift is caused by a major unexpected event. Think about how the pandemic instantly changed purchasing patterns or a major new competitor launching. And gradual drift is a slower evolution, like spammers constantly changing their tactics to evade filters.
So things are always shifting. How do you fight against that drift and keep your models accurate?
The main weapon is continuous monitoring. You need sisters, often AI-powered themselves, called drift detectors, that constantly watch the model's predictions and the incoming data. They raise automated alerts when performance starts to slip or the data looks weird. When drift is detected, the usual response is retraining the model with fresh, more recent data. Best practice involves managing all this from a central dashboard so you have a holistic view of all your model's health and performance over time.
And inevitably, we come back to data privacy and security. These AI systems need huge amounts of data, often sensitive data, that must create significant risks for businesses.
Huge risks. The sheer volume and often sensitive nature of data required for effective AI create unique challenges. One specific risk Dima mentions is something called a membership inference attack, MIA.
Okay.
This is where a malicious actor tries to figure out if a specific individual's data was part of the data set used to train your AI model. Think about why that's dangerous. If your model was trained on sensitive medical records, an attacker proving someone's record was in that dataset is a massive privacy breach.
Right. Confirming someone has a specific condition, for example. Scary. So what are the best practices to defend against that and other security threats?
It has to be a multi-layered defense. Strong data encryption is fundamental, both for data settings stored somewhere, at rest, and when it's moving between systems in transit. Strict access controls are vital, ensuring only authorized personnel can access sensitive data, often using multi-factor authentication. Techniques like data anonymization, removing identifiers, or pseudonymization, replacing identifiers with artificial ones, help protect individual privacy while still allowing data to be useful for analysis. And continuous data audits and security monitoring act as an early warning system for potential breaches or misuse.
Okay, we've covered the architecture, implementation, governance, but at the end of the day, for senior leaders, for business owners, the crucial question is, what's the value? How do we actually measure the return on investment for building this comprehensive AI forecasting capability?
Absolutely. You have to demonstrate tangible value. The basic ROI formula is pretty standard. It's the net gain from the investment divided by the cost of the investment. But DEMA makes a useful distinction between hard ROI and soft ROI.
Okay, what's the difference?
Hard ROI is the stuff you can easily quantify in financial terms. Increased revenue, reduced operational expenses, maybe lower inventory costs. Direct, measurable dollars and cents. Soft ROI covers the more intangible but still important benefits, things like enhanced brand reputation, improved employee morale because tedious tasks are automated, or the strategic value of developing new AI skills within your workforce.
And DEMA gives a way to estimate potential value, right?
Yes, he proposes a simple but useful opportunity formula to help prioritize projects. It's basically take your baseline key metric, like current error rate or cost, multiply it by a realistic range for the improvement factor you expect from the AI, say 10-20% reduction, and then multiply that by a scale factor representing how widely this applies across the business. It gives you a ballpark figure. For instance, if you have a chatbot handling 10,000 customer inquiries a month that used to take, say, 5 minutes each for a human agent, you can quickly quantify the labor hours saved and translate that into a monetary value. Helps make the business case.
That's a practical way to estimate potential. But what about real-world impact? Can we look at some examples across different industries where this kind of architecture is delivering results?
Definitely. The impact is pretty significant and widespread. In retail and e-commerce, for example, AI forecasting is dramatically reducing forecast errors. That means less money tied up in excess inventory and fewer lost sales due to stockouts. Plus, it enables hyper-personalization, which can cut down cart abandonment rates and boost average order values. Demand sensing, understanding subtle shifts in demand almost in real time, is another big win.
Okay, retail makes sense. What about manufacturing or logistics?
Huge applications there. Predictive maintenance is a classic example, using AI to predict equipment failures before they happen, slashing costly downtime. It also helps optimize inventory levels, reducing holding costs, and boosts overall operational efficiency. Think AI-powered route optimization for delivery fleets, saving fuel and time. I recently read about a manufacturing plant that used AI vibration analysis to predict a critical machine failure weeks in advance, avoiding what would have been a multi-million-dollar shutdown. That turns maintenance from just a cost center into a real strategic advantage.
Wow. And in sectors like finance or healthcare where the stakes are incredibly high.
In financial services, AI is transforming fraud detection and risk management, often catching sophisticated fraud rings that humans miss, saving banks huge amounts. Automation of routine back-office tasks is also driving significant operational cost reductions. And we're seeing more personalized financial advice powered by AI. In healthcare, predictive analytics is improving patient outcomes, for instance, identifying patients at high risk of hospital readmission, so proactive steps can be taken. It helps optimize hospital staffing and manage supplies more effectively. And as we mentioned, cognitive analytics is starting to help create personalized treatment plans by analyzing vast amounts of medical data.
It really sounds like a productivity amplifier across the board, freeing up people for more valuable work.
Exactly. And that applies cross-industry, automating mundane tasks, giving employees AI assistance to help them complete work faster. It adds up to significant labor hours saved and allows people to focus on the creative, strategic parts of their jobs.
So this architecture, this blueprint, it's clearly not a one-and-done project. It's an ongoing journey, an evolution. Looking ahead, how does an organization mature its AI capabilities over time to maintain that competitive edge?
That's where thinking about AI maturity comes in. DEMA references McKinsey's AI maturity model, which is a useful framework. It outlines roughly 5 stages. You start at ad hoc foundational, where maybe there are isolated AI experiments, but no real strategy. Then developing approaching, where you see simple automations, maybe some internal projects, initial proof of concept starting to work.
Okay, dipping your toes in.
Right. Then you reach mature. Here, there's a formal AI strategy. AI is being rolled out across multiple projects, and you're seeing measurable efficiency gains. Moving up, you get to leading. At this stage, AI adoption is company-wide, integrated into core processes, and it's actively providing a competitive advantage through innovation. And the top stage is transformative. Here, AI is so deeply embedded, it's actually redefining core business processes, maybe even enabling entirely new business models. It requires maximum investment, but delivers maximum value and agility.
And Dima's blueprint helps companies move through these stages.
Exactly. The layered architecture provides the foundation and the scalability to support that journey, guiding organizations as they move from initial experiments towards becoming truly AI-driven leaders.
That's a clear path for growth. Now, looking even further ahead, what are some of the emerging technologies on the horizon that might shape the next evolution of this blueprint? What should leaders be keeping an eye on?
Well, the field is moving incredibly fast, but a few things stand out. Reinforcement learning, RL, is one. We talked about predictive and prescriptive, but RL goes a step further. Think of it like an AI learning through trial and error, like learning to play a game. It makes a decision, sees the outcome, gets feedback, a reward or penalty, and adjusts its strategy. This makes it incredibly powerful for optimizing really complex dynamic systems where the right answer changes. Constantly think real-time supply chain logistics or dynamic pricing in volatile markets. It learns optimal strategies by interacting with the environment.
So learning by doing, essentially for complex systems. Interesting. What else?
Generative AI for strategic planning is another fascinating area. We mostly hear about generative AI for creating text or images, but its potential and strategy is huge. Imagine AI systems processing vast amounts of market data, competitor intelligence, economic forecasts, then simulating complex business scenarios, identifying potential opportunities or risks that humans might miss, and even generating drafts of dynamic strategic plans. It won't replace human judgment, but it could massively augment it.
A strategic co-pilot almost.
In a way, yes. And finally, composite AI is a key trend. This is about moving beyond relying on a single AI technique. Instead, future architectures will likely integrate multiple AI technologies into a single, more robust system. For example, combining the pattern recognition of machine learning with the language understanding of NLP and the visual interpretation of computer vision. This multimodal approach allows AI to understand situations with much more nuance and sophistication, leading to better, more context-aware forecasting and decision-making.
This has been a fascinating deep dive into Dmytro Golodiuk's AI-driven forecasting architecture in enterprise. It really lays out a clear, actionable blueprint for transforming how businesses operate, shifting from being reactive and backward-looking to being proactive, foresight-driven, and truly harnessing data as a core strategic asset.
And I think the crucial takeaway thing to really emphasize is that success here isn't just about having the latest AI technology. That's necessary but not sufficient. It fundamentally hinges on getting the foundations right. Robust data quality, a dynamic and ethical governance framework, and a relentless strategic focus on empowering your people and optimizing your processes. Those are the non-negotiables for turning this blueprint into genuine, sustainable competitive advantage.
Absolutely. And this isn't some far-off future vision. Dima's work provides a practical guide for today's senior leadership, for chief enterprise architects, for technology strategists, anyone tasked with building a more resilient, intelligent, and ultimately future-proof enterprise.
So perhaps the final thought to leave everyone with is this. Thinking about your own organization, what's the single highest impact business problem that this kind of AI-driven forecasting could solve for you? And perhaps more importantly, what's the very first practical step you take this week towards making that a reality?
Thanks for tuning in to Archicraft. This episode was generated using AI from Dmytro Golodiuk's blog at demongo.com/news. If you enjoyed this episode, follow the show on your favorite platform and share it with fellow architects and engineers. Until next time, build smart, architect with intent.